Hello and welcome to this MCUXpresso Shorts video in which I'll be showing you how to build the i.MX RT loader in MCUXpresso. This guide is an update from the original guide which is linked to in the introduction text. Here we can see the MCUXpresso project opened in MCUXpresso with its various targets. For details about importing it, please see the original video. This new video shows that the project has been made more simple to control. If we open up the properties and we move to the build variables, here we can see that we have some global variables which are relevant and shared by all of the targets. Now it's important that when I change these, I change them to be valid for all configurations. And at the moment we see that we would be building for the RT1010 board. Now for illustration purposes I'm going to modify this and we're going to build a project now for the 1020 board instead. We see some other strings here. I'll very quickly explain what these are. We've already seen the target board, which is going to control the board which we're going to be building all of the loader steps for. We then have a magic number which is responsible for verifying that we don't load the wrong firmware to the wrong target later on. And we also have an authentication key so that the bootloader can be very sure that the new firmware has been built by a reliable source. When we use a high level of security, we have here the AES256 key, which here is a string for simplicity, and the corresponding initial vector. Now this key is shared for the AES256 encryption and also for AES128 encryption if on-the-fly decryption is used directly from the QSPI flash. The strings here obviously have to match with the strings which we have in the code itself. Now that we have the board set up, I'll show you how to build each step in the bootloader. We always start by building the bare minimum bootloader, which is the first one here. Before I start building, I'm going to have a look at the target location on my hard drive. This is the directory where our output files will be located to. I've also cleaned this directory out for clarity, and now we can start the build. Here we can see that the build was successful. And if I switch back, we will now see that we have an image which is called MCUXpresso boot with the name of our board. Now this file cannot be used on its own, instead it's going to be used as input to our second step. So now we choose the MCUXpresso Fullback loader. And again, before I build, I'm going to check my output directory location. Again, I've cleaned it out for clarity purposes, and we can now build the Fullback bootloader. After the build has successfully completed, we again look at the output directory where we see MCUXpresso Fullback loader image, and again with the name of our target board. Now we could load this to the board now, and what would happen is we would have the MCUXpresso bare minimum loader combined together with the Fullback loader, which is now an operating application allowing the serial loader to be loaded. But I prefer now to move on to the next step where we're going to build the serial loader. Now we move to the MCUXpresso serial loader build and we allow that to execute. Now we can see that when this executed completed, we now have a MCUXpresso serial loader update file, again with the target name. This we could load to the Fullback loader. Alternatively, we now have also a MCUXpresso boot complete image for this target, which we could load to the board, and then it would already contain the bare minimum loader, the Fullback loader, and the serial loader. And now that we have the loader complete, we can start building applications. Here I have the MCUXpresso application ready to build. First of all, I'm going to build the ITC version, which means that it's the version which will run from internal RAM, assuming that we have enough space in the internal RAM to allow the code to run. Again, as the build completed, we see that our output directory is filled with the files which we can then load to the board, which are our application. We have this in several versions. The first version that we have is a complete combination of the bootloader, that means the bare minimum bootloader, plus the Fullback loader, plus the serial loader, plus our application. That means that we have quite a big file because we have all of these 4 different programs already integrated into it. We could load that to our board and already have the complete loaders and also the initial application. This would tend to be used for production programming. The second file here is an AES-256 encrypted version of our application, which we can load to the board via the serial loader. Here we have the complete image again in hex format. Now that's useful for Teensy 4 users because they need the hex format to load to their boards. And again we have the application in the AES-256 encrypted version as an S-record, which can be used for uploading to the board via techniques which require S-records rather than binary files. Moving on, I have 2 further possibilities. I can build a standalone application. I'm not going to show this because it's not that interesting in fact for the project. We would tend to use either the encrypted internal flash version, or if we have very big programs, the XIP, that means the execute in place version, which can be still be uploaded via the serial loader. So let's build this one as well. And again I'm showing you the output directory used for the generated images, and we see that we have in this case 2 images which are generated. Here we have the XIP one for our target. Now that is a plain code version. Let's have a quick look inside of it. Here we can see it's an unencrypted file, very obvious by the plain text strings which we see inside of it. This can be uploaded to the board via the serial loader, and then we have an AES-128 encrypted version. So if we look in here, we will then obviously see that we don't recognize a lot of stuff in there because it's strongly encrypted, and this version we can also upload via the serial loader, and the serial loader will then execute the on-the-fly encryption which is needed to allow it to operate. It's worth noting that since we built for the i.MX RT1020 board, this will be encrypted in a form which is suitable for the BEE on-the-fly encryption unit to work with. If we were building for the 1010 board, which doesn't use BEE, that means bus encryption engine decryption, it has a different module inside which does something similar, but it's called OTFAD. The encryption used here would be automatically suitable for operation using the OTFAD module instead. Now normally the bootloader itself would only need to be built once for a certain product. Afterwards it would only be the application which needs to be built. The concept means that you have very flexible bootloading techniques for the serial loader, and also integrated over-the-air support for those with large programs which need to run using the on-the-fly decryption module. You automatically get a solution without having to do any more work at all. Now here I've showed the MicroTasker application being used, and also I do advise using the MicroTasker application for real product developments because I'm convinced that it will allow the developments to be achieved much faster than using the more traditional approaches. However, if you're using SDK code, you can also use SDK generated applications to run with a MicroTasker bootloader, including on-the-fly decryption. I'll be making another video showing exactly how to do this a little bit later. Thank you for watching, and good luck with your own developments using the MicroTasker i.MX RT loader in MCUXpresso.